equations of motion. These equations of motion you have studied in your previous chapter. V is equal to u plus at. V is final velocity of any moving object. कोई भी चीज अगर मोशन में है then its final velocity is v, initial velocity is u, a is acceleration and t is time. S is displacement of that moving object. कोई भी चीज अगर मोशन में है then the displacement is given by s, ut plus half at square. And third equation is time independent equation. V square is equal to u square plus 2as. This third equation is usually used when we don't have the value for time. और यहाँ पर ना, remember one thing, except t, time, all the quantities are vector quantities. Vector quantity, it has got magnitude as well as direction. That's the reason when you substitute the values for all these quantities, you have to follow sign convention. Forward direction अगर positive है, backward direction will be negative. When you substitute the value for any vector which is in backward direction, the value will be negative. Similarly, if upward direction is positive, downward direction will be negative. Accordingly, values substitute करने हैं, positive and negative. Now see, these three equations are equations in general. इसी equations को if we are using it in terms of gravity, motion because of gravity, then these equations are mathematically same, लेकिन notations और symbols थोड़े से change हो जाते हैं. Like this. V is equal to u plus gt. When motion is because of gravity, acceleration will be acceleration due to gravity. और यहाँ पर ना usually upward direction is considered positive and acceleration due to gravity is always downwards. So g का value usually negative आता है, but not every time, depending on situation. H is equal to ut plus half gt square. H is what? Height. Usually height from which an object is falling, or else if an object is thrown upwards, how much height it is reaching, वो calculate करने के लिए we use this equation. So s की जगह h आ जाएगा. But remember one thing, if you check out in your textbook, h is usually considered as a scalar quantity. It has got only magnitude. लेकिन यहाँ पर when you substitute the values of h, you have to follow sign conventions. क्यों ऐसे? Because although height is scalar and displacement s is vector, they are numerically equal over here. We are calculating height by calculating s, that is displacement. So, because displacement is a vector quantity, it has got sign convention. So, यहाँ पर height का value के लिए भी साइन कन्वेंशन फॉलो करना है. थर्ड इक्वेशन इज ऑब्वियसली v स्क्वायर इज इक्वल टू u स्क्वायर प्लस 2gh. यहां पर भी यू हैव टू फॉलो द साइन कन्वेंशन. नेक्स्ट टॉपिक इज मास एंड वेट. दिस इज वेरी सिंपल. मास बोले तो वजन, वेट मीन्स ग्रेविटेशनल फोर्स. F is equal to m into a by Newton's second law. Weight W is equal to m into g, acceleration due to gravity. Therefore, weight is proportional to mass. If mass is more, gravity is more. Weight is proportional to acceleration due to gravity. If g is more, weight is more. That's the reason on polar regions weight is more and on equator weight is less. ये हमने देखा था ना पहले. Same thing is applicable here. Oh wow! हमारा चांद, our moon. If you land on moon, do you know how much your weight will be? Your mass will remain the same, but weight will decrease. कितना कम होएगा? What will be the weight on moon? चलो वो भी पता कर लेते हैं. Let us calculate. सबसे पहले let us collect all the necessary data, necessary information. M suffix E is mass of Earth, पृथ्वी का वजन 5.98 into 10 raised to 24 kg. I know usually 6 बोलते थे, लेकिन यहाँ पर it is mentioned as 5.98. These values won't be fixed. आपको जो दिया रहेगा ना in problems or theory wherever, जो value आपको दिया है that you have to follow, that you have to use. M suffix m, that is mass of moon is 7.36 into 10 raised to 22 kg. Now you may come to the conclusion that mass of moon is more than the earth. गलत, ऐसा नहीं है. Look at the power of 10. 10 raised to 22, and for earth it is 10 raised to 24. 10 raised to 22 is 100 times less than 10 raised to 24. So you can say mass of moon is almost 100 times less than that of earth. RE, radius of earth is 6.37 into 10 raised to 6 meters. Rm is 1.74 into 10 raised to 6 meters. Over here दोनों जगह पर 10 raised to 6 is common. However, instead of 6, 1 के terms में आ रहा है. So radius of moon is 6 times less than that of earth. Gravitational force is capital G into capital M into small m upon d square. ये तो हमने सीखा है. So substituting that for weight on earth, we get this. WE is equal to G into ME into small m upon RE square. Instead of capital M, it will be mass of earth, and distance will be, D will be radius of earth. Similarly, for moon, we get this. Let us compare both of them and see. Therefore, WM upon WE will be how much? सबसे पहले WM का substitution करते हैं. We get this. And we are dividing Wm by We. So it is divided by this. And when we are dividing by any fraction, it is obviously we mean we are multiplying by the reciprocal of that fraction. So this same equation can be rewritten like this as well. Multiplied by the reciprocal. G cancel होता है, small m cancel होता है. We get this. Rearranging m together and r together, we get this. And power which is there, square, cube, raised to 4 वगैरह, they can distribute over multiplication as well as division. बोले तो re square upon rm square can be written as re upon rm whole square. Square distributes over division or fraction. Substituting, we get this. इसका value approximately is equal to 1 by 6. Therefore, we have Wm is equal to 1 by 6 into We. Weight on moon is 1/6 of the weight on earth. अगर आप चांद पे जाओगे ना, you will get a feeling. ऐसा feeling आएगा as if your weight has reduced 6 times. 6 गुना कम हो गया, ऐसा feeling आपको आएगा. If you take a spring balance and measure 6 kg, and if you take the same object on moon, it will measure as 1 kg because weight reduces 6 times. And one more thing, weight has reduced 6 times बोले तो gravitational force on moon is 6 times less than that of earth. इसलिए if you stand on moon and jump, उड़ी मारोगे, what will happen? Earth पे you can jump 1 feet high, right? 1 फुट ऊपर उड़ी मारते हो. On moon, you can jump 6 feet high or even more than that. That's the reason astronauts वगैरह when they land on any other planet, उनको strictly बोला जाता है उड़ी नहीं मारने का, don't jump. You will go out of control. किधर भी चले जाओगे.